This is a short module on the concept. Visit mockat.com to access the complete concept video, practice questions, quiz of the day and other free resources to start your prep right away.
Now we should look at a few important algebraic expansions, right? So we'll start with the most important one, which is a plus b whole power n, right? So before we get into this, I need you to understand the expansion for NCR, right? So this is covered under permutations and combinations once again. NCR equals n factorial divided by r factorial into n minus r whole factorial, right? So 5c2 for instance is going to be 5 factorial divided by 2 factorial, right? That is r factorial into 5 minus 2, right? N minus r, 5 minus 2, which is 3 factorial, right? So on simplification, 5 factorial by 3 factorial is 5 into 4, right? We discussed this earlier. 5 into 4 into 3 factorial, that gets cancelled. 5 into 4 is 20, 20 by 2 is 10, right? So 10 is the answer here. Now the expansion of a plus b whole power n involves a bit to do with the NCR, right? So what is the expansion? It's going to be NC0 into a power n b power 0 plus NC1 into a power n minus 1 b power 1 plus NC2 into a power n minus 2 into b power 2 and goes on, right? Let's say it continues over here. And what are your last terms going to be? Last but 1 is going to be NC n minus 1, right? Last but 1 into a power 1 b power n minus 1 plus NCn, your nth term, to a power 0 into b power n. Now if you're seeing this for the first time, it will seem a little complicated, right? Let me once again write it as I explained to you, right? The way you should remember. A plus b whole power n equals, your first term is going to be NC0, right? The next term is going to be NC1, NC2 and so on. Your last few terms are going to be NCn minus 1 and NCn, right? So let me just leave some space over here and write it. NCn over here, right? All these are going to be added, okay, right? And you have dot dot dot. This is what we get. Now what's your first term going to be? The first term, the power of a or b, we can start with either of them, right? Let's say a over here to the power of n. Now for every subsequent term, a's power is going to reduce by 1. It becomes a power n minus 1, a power n minus 2 and so on. Now another way to look at the same is the power of a is going to be n minus r, n minus 0, n minus 1 over here, n minus 2 over here and so on. Here it's going to be a power n minus of n minus 1, which is 1. The last one is going to be n minus n becomes 0, right? So two ways to look at it, either the difference of these or start with n and it keeps reducing by 1. Now b's power is going to start with 0, right? Which is this r part itself, right? Here it's going to be b power 1, here it's going to be b square, here it's going to be b power n minus 1 and lastly we have r as n, so it becomes b power n over here. So just practice this a few times, right? So it should become really easy for you. Just one last time, right? So we start with NC0, then a power, the full n, b power 0 plus, now NC1, this increased by 1. The power of a is going to reduce by 1, b is going to increase by 1. Next NC2, a power n minus 2 reduced by 1, b increases by 1 becomes square. Right? So this continues and finally we get NC n minus 1, a power, now it becomes just 1, b power n minus 1. Right? And the last is going to be NC n itself, a power 0 it becomes and b becomes the full n. Now portions of this expansion will be used in different concepts like remainders with exponents and so on. So it's important for you to understand how this formula works. Now it will specifically be used in questions involving a step like this, a plus b whole power 43. You might be asked for the last two terms, right? So they're going to be 43c 42, right? A power 1, b power 42 plus 43c 43, a power 0 and b power 43. 43c 42 is 43 itself into a b power 42 plus 43c 43 is 1 and a power 0 is 1. You get b power 43, right? So steps like these might be required in certain questions. So have a good understanding of this expansion. Next up, you need to know this. A power n minus b power n equals a minus b into a power n minus 1 plus a power n minus 2 into b plus a power n minus 3 into b square. So what are we doing here? The first power over here is a power n minus 1 into b power 0. I've just not written it, right? B's powers are going to increase from 0 onwards to 1 here, right? A power n minus 2 into b power 1 plus a power n minus 3 into b square, right? And this continues. Your last two terms, let me write it. The powers are going to get switched over here, right? So it becomes a power 1 into b power n minus 2 plus your last one is going to be simply b power n minus 1 itself into a power 0, but you can choose not to write it. Now what happens when you expand this, right? We're just going to get this. You can just expand and just verify. A into a power n minus 1 is a power n. Minus b into this is minus a power n minus 1 into b. A into next term is going to give us a into a power n minus 2 is a power 1 plus n minus 2. Powers can be added and you get n minus 1 into b power 1, right? Next, minus b into this would give us a power n minus 2 into b square. Likewise, a into the next term over here is going to give us plus a power n minus 2 into b square. And this continues, right? So what's your last term going to be? Let's just look at the last terms. Plus ab power n minus 1 and you have minus b power n, right? How does this look? A power n is as it is. Look at the next two terms over here. Minus a power n minus 1 into b and plus a power n minus 1 into b. They're the same, right? One is minus and the other is plus. You can cancel it. The same with these two. And this process will continue till you're left with the first and the last terms. And what are they? A power n minus b power n, which is what this is. Once again, write this along with me now. A power n minus b power n equals a minus b into a power, start with n minus 1, all right, into b power 0, you don't need to write it, plus, always plus over here, a power n minus 2 into b power 1 plus a power n minus 3 into b square, right? You're reducing this power by 1, a's power by 1 and increasing b's power by 1 for every subsequent term. Alright, so what do we get? N minus 4 into b cubed, and this continues till we are left with, let's say, a power 1 into b power n minus 2 plus just b power n minus 1. So what do we note over here? A power n minus b power n will always have a minus b as a factor. What do I mean by that? 13 power 8 minus 5 power 8 is always divisible by 13 minus 5. Why? This term over here is 13 minus 5 into something, which is nothing but 8 into something, right? If the expansion of this is 8 into something, that means this particular term is an 8 multiple. So therefore 13 power 8 minus 5 power 8 is always divisible by 8. Likewise, a 97 power 97 minus 15 power 97 is always going to be divisible by the difference between 97 and 15, right? So which is 82. So you could be given a question wherein you're asked 97 power 97 minus 15 power 97 is always divisible by which of the following, and you could have 41 as one of the options. You got to choose that, because if this is divisible by 82, that is 97 minus 15, then it's definitely divisible by a factor of 82. 82 is 2 into 41. Therefore, it's definitely divisible by 41 as well. Now, this table over here, right, it looks like too much, which is cramped up over here, right? So this you need to be in a position where you're able to recall each and every expansion which is listed over here, right? The first two we discussed, a plus b whole power n and a power n minus b power n. The next two you should be knowing. A plus b whole square is a square plus 2ab plus b square, right? And a minus b whole square is a square minus 2ab plus b square. Now on to the next two. A square minus b square is a plus b into a minus b. You have read this in school, right? Should remember this. Now a square plus b square can be written in two ways, right? So look at this particular one. A square plus b square is a plus b whole square minus 2ab. Take the minus 2ab to the other side and you get this. In the above one, right, from here what do we get? A square plus b square is a minus b whole square plus 2ab, right? Plus 2ab. If you just expand these, your 2ab's will get cancelled and you get a square plus b square. Now a plus b whole cube can be written in two ways. They're pretty much one and the same, right? So the way you would have learnt it in school is a cube plus b cube plus 3ab into a plus b, right? In fact, this is the way I remembered, or I learnt. And a minus b whole cube is a cube. Just put a minus for all of these pluses, right? Minus b cube minus 3ab into a minus b. So these are your first two over here, right? The next two are simply the expansion, right? You multiply 3ab with a plus b and same over here, and you would get these, the bottom two, right? Now a cube plus b cube and a cube minus b cube. Now first up from this, I should be able to write a cube plus b cube as, take the 3ab to a plus b to the other side, a plus b whole cube minus 3ab into a plus b, right? So that's one way of writing, which is over here. Now for the a cube minus b cube part, right? So what do? It's a minus b whole cube. You take the minus 3ab to that side, it becomes plus 3ab into a minus b, right? So which is this part. There is, however, one more way of representing which you should know, right? Which is a cube plus b cube equals a plus b into a square. As we had a plus over here, we need to create a minus ab plus b square, right? Please memorize this. A cube minus b cube equals a minus b into, right? We started with a minus, so you have only plus over here, a square plus ab plus b square. Now how do we get these two, right? You just take a plus b common and then expand the rest, and you'll see that, you're going to be getting this. Likewise for the bottom one, take a minus b common from these two and put the rest inside, and you would be getting this. But you can't be deriving this from this in the exam, so you should be memorizing this part as well. Now on to a formula which is often used as well. A plus b plus c whole square is a square plus b square plus c square plus 2ab plus 2bc plus 2ca, right? Now a cube plus b cube plus c cube minus 3abc, right? So this is an interesting thing. This is a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca, right? So need to remember this. Now as a special condition, if a plus b plus c, if this term over here, if this becomes 0, right? If a plus b plus c is 0, then the entire right hand side is becoming 0, right? So this can be written as a cube plus b cube plus c cube minus 3abc equals 0, which means a cube plus b cube plus c cube equals 3abc, right? Which is what we get over here. Now there are two other special properties which you need to remember, right? The first is this: a power n plus b power n is always divisible by a plus b if n is odd, right? So start this way: if n is odd, then a power n plus b power n is divisible by a plus b. If n is even, right, then a power n minus b power n is divisible by a plus b. Yeah, once again note that in the denominator you have a plus b in both the cases, right? It's a plus b in both the cases, right? Now you'd be wondering, what about a minus b? Now we've seen over here, right? A power n minus b power n is always divisible by a minus b, right? Because the expansion, you have a minus b into something. Right? These two properties over here are for a plus b. Once again, if n is odd, a power n plus b power n is divisible by a plus b. And if n is even, right, then the minus part over here, a power n minus b power n, is definitely divisible by a plus b. On to example 13. The remainder when 15 power 23 plus 23 power 23 is divided by 19, right? So when you divide this by 19, what do you get as the remainder, right? So here we have a power n plus b power n, right? You have 23 in the power in both the cases. And 23 is an odd number. So what do we know about odd numbers, right? So 15 power 23 plus 23 power 23 is definitely divisible by a plus b, right? Where you have the same power and it's odd, then it's definitely divisible by 15 plus 23, right? Now what is 15 plus 23 over here? This is nothing but 38, right? So this is definitely divisible by 38. If a number is definitely divisible by 38, then will it definitely be divisible by 19? Yes, because 38 over here is nothing but 19 into 2 When you're dividing 38 perfectly, then you're definitely divisible by 19 as well. If you're perfectly divisible by 19, then what's the remainder going to be? 0, right? So you're left with a remainder of 0. Option 3 is the correct answer here. Once again, if you know the concept, right? So calculation, there's nothing much over here, right? Should be able to answer it quickly. On to example 14. Now, r equals 30 power 65 minus 29 power 65 divided by 30 power 64 plus 29 power 64. I need to see as to where r sits over here, right? Which range over here correctly defines where r is going to fall, okay? It's a power n minus b power n. I'm not looking for whether it's divisible by some number. So I probably need to apply the expansion of a power n minus b power n, right? So what is that going to be? R equals a minus b, right? 30 minus 29 into a power n minus 1, right? 30 power 64 plus 30 power 63 into 29 power 1 plus 30 power 62 into 29 square, and this continues. And what do we get towards the end? The last term is going to be 29 power 64. The last but one would be 30 into 29 power 63, right? So you don't need to be so precise for this question. We'll see why. Now this is being divided by 30 power 64 plus 29 power 64, right? Now it's easier to look at. Why? 30 minus 29 over here is 1. So this equals, in the numerator now I have a 30 power 64 and a 29 power 64. Let me write those two initially, right? Plus 29 power 64. And then let me write the rest of the terms. 30 power 63 into 29 plus 30 power 62 into 29 square, and so on, right? The last term we know is 30 into 29 power 63, right? So let me group these up separately and divide by the respective, or rather the same denominator here, right? I'm separately dividing them. And what do we get here? Here, these two divide perfectly because they're the same, and we get 1. So the answer for this is going to be 1 plus some number. And this is a positive number, right? It could be 0 point or more than that. Doesn't really matter over here. But I know it's 1 plus some positive number. R is going to be definitely greater than 1, right? Option 4 is the correct answer. It's definitely not less than 1. Now there are a few other things which I need you to memorize, right? So first up, the tables, right? So tables, if you can know it till 15, right? So till 15, till 10 you would have learned it in school, or even till 12, right? I need you to know it till 15, and a bonus is going to be tables from 16 to 19, right? 16 to 19 into 1 to 6, right? 16 to 19 into 1 to 6. This part over here, let me write it clearly. 1 to 15 or 2 to 15 into 1 to 10. Again, I need you to know it like the way you know 2 into 6 is 12 or 4 into 6 is 24. You should be able to say 13 into 7 is 91, 14 into 8 is 112, and so on. Now, why is this important? Because this examination is as much about speed as it is about accuracy. You've got to be quick in answering questions. So therefore, this will really help you a great deal when you're answering questions. Now, likewise, the squares, all right? So up to 32 square, if you can memorize, it will be useful because these have turned up quite often. 33 square, if you want, you can add in over there, 1089, right? These you should know at the back of your head, right? So if it's 21 square, it should be 441, or 29 square is 841. Now you've got to be really quick at answering these. Now the best way to learn or memorize this is going to be looking at these in the morning and evening, right? So the gap of about 12 hours, look at it for about 5 minutes and 5 minutes. And in about 5 to 7 days, you'd be in a real good position. If you do this consistently for about 1 to 2 weeks, right, I think it should be done for you. It'll be very difficult to forget it after that. Now, what I mean by it's difficult to forget is the same way it's difficult for you to forget that 6 into 2 is 12, right? So please keep looking at this over and over again till you have memorized this really well. And these are some of the powers which I need you to memorize as well. In the sense 2 part 12 is 4096 or 5 part 6 is 15625. Now, knowing these by heart is going to really help you in some of the CAT questions. See that every year at least 1 to 2 questions where direct application of these will be there, right? So it should really speed up your, rather reduce the time taken for you to solve these questions. The same approach you need to follow once again over here, right? Keep looking at these twice a day for about a week to 10 days or 2 weeks, and you should have done this by then.
If you found this video useful, please like and share it. Subscribe to the channel and let us know what you'd like to watch next in the comments below. Don't forget to visit Mockat.com to access free resources to get through your Dream B School.